In this lesson, you will use permutations and use combinations. So a permutation is an arrangement or listing in which order is important. So I want you to think about this word permutation. The first four letters are perm, and when someone is giving you a perm, is the order in which they put things on your head important? Absolutely. You don't want them to burn your scalp. So order is important when someone's giving you a perm. So remember, permutation is when order is important. Here's a situation where it might be important. Taylor plays softball, and her coach told her that she would bat sixth in the softball game. So could we list Taylor more than once in the lineup? No, order is important there. When the coach chooses a group of batters, is the order in which the coach chooses the batters important? Well, yes. In softball and baseball, we usually have someone bat cleanup, which means they're fourth in the lineup, and they're the person maybe that has the highest batting average. So the group of batters, the order in which I choose them for the different slots is important. When the coach lists the players in the lineup, is the order in which they're lined up important? You can only have 9 players. And so the order I put those players in, if it's a batting order, it has to stay in that order. So order is important in that situation. Now, the fundamental counting principle is when you list all the possible outcomes. Let's just take the first 4 batters. Let's just say that the first 4 batters are A, B, C, and D, a name that starts with A, B, C, and D. So all the options I have are, I could have A, B, C, D go, I could have A, B, then D, then C, and those are my options with A, B first. And then I could have A, D, and A, D, and we could keep going. Well, this is going to take a long time. In fact, there's going to be 24 total ways, and I would really probably run out of room. There's a faster way to count, and what that way is with a factorial. If I take 4 times 3 times 2 times 1, that gives me 24, and that's how many outcomes there are for the first 4 slots. Let me make a little bit more sense here. A factorial, the expression is read, this is read 0 factorial, and this is read 5 factorial. When n is greater than 0 is the product of all positive integers beginning with n and counting backwards to 1. So 0 factorial is 1. 5 factorial is 5 times 4 times 3 times 2 times 1, which when you type this in is 120. How do you type this in? On your calculator you have the PRB key. This means probability. And you have to scroll over 3 to the exclamation point. You have to hit the number first. So let's just try this together. Type in 5, PRB, scroll over to the exclamation point, hit equals, and you should get 120 out on your screen. If you don't, rewind it and watch that again. So here's how we would count. A travel agency is planning a European vacation package. How many ways can the agency arrange the 5 cities along the tour? Well, that's going to be, I have 5 options for the first city. Well, I went there. Now there's 4 options for the next city. Now there's 3 options for the third city, 2 options, and finally we visit the last city. That's 5 factorial. And we just did that, so there are 120 ways that you can arrange the cities along the tour. So you try an example in your notes. Suppose Taylor's coach had 5 players in mind for the first 3 spots in the lineup. So how many different batting orders could she make? This is called a permutation because order is important. Remember we said order was important in the batting order. And the 5 represents how many players I have, or your total. And then this 3 represents how many you are choosing. So this coach has 5 players and the coach is choosing 3. The formula for a permutation is NPR, N meaning the total number, and R meaning the number you're choosing, as N factorial over N minus R factorial. So if I wanted to use this formula, I would say 5 factorial for this situation up here, over 5 minus 3 factorial. So it's really 5 factorial divided by 2 factorial. Now you can try that on your calculator, do 5 factorial divided by 2 factorial, but let me tell you, there's a key that will do this for you. On your calculator, if you type in PRB, you have these 2 keys that pop up, an NPR and an NCR, and then you have the factorial. This is what we're talking about. This is a permutation. So you would type in first your 5, your N, your number or total that you have, and then you hit PRB, NPR, and then you tell me how many you're choosing, and it'll give you that answer. There are 60 orders that this coach could do. Now you can do it the long way, or you can do it the short way with the PRB key and the permutation key. It's up to you. Let's do one more example, and then you can try one in your notes. Mrs. Bricker is placing 6 out of 10 magazines in a school showcase. How many ways can she arrange the magazines in the case? Is order important here? Yes, because she can't place the same magazine back to back. They're different magazines. So this is going to be a 10 permutation 6. Why? Because there's 10 total magazines, and she's choosing 6. So if you want to use the formula, you can use the formula, and you can say, okay, that's 10 factorial over 10 minus 6 factorial, which is 10 factorial over 4 factorial, and simplify it out. Go the long way, that's fine. Or I can use my permutation key. I type in 10, my permutation of choosing 6, and I get 151,200 ways that she can arrange the magazines in the case. You try an example in your notes. Now, Taylor's coach doesn't care who is in which spot, just that the players are in the lineup. So she has Angie, Beth, and Taylor, and she doesn't care who bats where. That's a combination. An arrangement or listing when order is not important. And it's going to be the NCR key. Above that PRB, you have an NPR, an NCR, and an exclamation point. We're talking about the NCR. And it's N factorial over N minus R times R factorial. Here's a situation. Braden works part-time at a local department store. His manager asked him to make a display using 5 different styles of shirts from 8 available styles. How many ways can Braden choose the shirts? Is it okay if Braden repeats a style of a shirt? Well, yeah, that's totally fine, because he has 8 different to choose from. So we're going to do an 8, choose 5, a combination. Here's his total shirts, 8, and he's going to choose 5 from that. Now you can fill out the formula if you would like and do 8 factorial over 8 minus 5, which is 3 factorial, times 5 factorial. Now, when you do this, this is 3 times 2 times 1 times 5 times 3 times 2 times 1. I don't know about you, but I think the key is going to be way easier than this. So I type in my 8, PRB, I scroll over to my NCR, and then I'm going to just hit that key, and it's 56 ways. Order didn't matter here. He could have 2 different styles of shirts back to back, and that would be okay. Now, in permutation, order matters. In combination, order does not matter. So what about this situation? A playlist of songs on a digital media player is being played so that songs do not repeat. And how many ways can the songs be played? Does order matter here? Is it okay if I have a song back to back, like the same song? Well, we just said here we don't want the songs to repeat. So that is a permutation because we do not want to have that repetition. Rudy orders an ice cream cone with 3 different flavors. There are 26 possible flavors. How many different sets of the 3 flavors can he choose? Like, could he do a vanilla, chocolate, vanilla? Is it okay if he repeats that vanilla? Yeah, that's totally fine. Rudy's going to be okay with that. So that's a combination because the order of the flavors do not matter. So you try the examples in your notes. The last thing that we're going to do is talk about probability with your combination or permutation. The Spanish Club is forming 2 teams for an international festival. Now, Avery and Lacey are among the 9 students who volunteered to lead the team. So I have 9 students, and there's 2 girls, Avery and Lacey. Now, the advisor wants to assign positions at random. Now, is this order going to matter? Could Avery be in both positions at once? Well, no. So this is going to be a permutation because order matters. So we do our 9, choose 2 here, and you get 72 total ways. Now, if the advisor assigns a position, what's the probability Avery would be chosen? And Lacey would lead the tickets. Well, there's 72 total ways, so that's going to be our denominator. Because remember, probability is the number of outcomes you want out of the total outcome. So 72 is going to be our denominator. How many outcomes would I have Avery B food and Lacey B tickets? That's only going to happen one time that each girl gets that one slot. So the probability here would be 1 out of 72. So you try the example in your notes.